Hello students. I hope everyone is doing well. Today we will discuss chemical changes, but before going into that, let us see the differences between physical and chemical changes. Physical change is when a substance undergoes a physical change, its composition remains the same despite its molecules being rearranged. While, when a substance undergoes a chemical change, its molecular composition is changed entirely. Thus, chemical changes involve the formation of new substances. Physical change is a temporary change. In contrast, a chemical change is a permanent change. A physical change affects only physical properties, while chemical change changes both physical and chemical properties of the substance, including its composition. In a physical change, the energy exchange is either minimal or non-existent, while energy exchange can be clearly seen in a chemical change. In a physical change, a new substance is not formed, and the process is reversible, while in chemical change, the formation of a new substance can be seen at the same time. It is usually irreversible. After our discussion on the differences between chemical and physical changes, let us see the different types of chemical change. When we are considering chemical changes, we must consider chemical reactions. So, now let us see the different types of chemical reactions. The first one is a combination reaction, then decomposition reaction, followed by displacement reaction, oxidation, and reduction reactions, and lastly double displacement reaction. The first one is the combination reaction. Two or more compounds combine to form one compound. It can be explained as A plus B gives AB. For example, when hydrogen reacts with chlorine to form HCl or SO2, reacts with O2 to form SO3. Likewise, ammonia reacts with HCl to form ammonium chloride. Next is the decomposition reaction. In this, a complex molecule breaks down to make simpler ones. This can be explained as AB gives A plus B. For example, when ammonia is decomposed to form nitrogen and hydrogen. Also, the decomposition of PCl5 to give PCl3 and Cl2 is another example of decomposition reaction. Followed by this is displacement reaction. In displacement reaction, one element takes the place with another element in the compound. To understand it better, we can represent it in a general manner as A plus BC gives AC plus B. An example of a nonmetal displacement reaction is this. NaCl reacts with fluorine to form NaF and chlorine gas. Also, there is a metal displacement reaction where, like in the nonmetal displacement, more reactive element replaces less reactive element, but the only difference is that in this metal is being displaced, while in the earlier nonmetal is being replaced. For example, metal displacement reactions are reaction of CuSO4 with Zn, forming ZnSO4 plus Cu. One more example that we can see is CuSO4 with H2, giving H2SO4 plus Cu. Remember, H2 can replace a few of the less reactive metals from their respective salts, and this also comes under metal displacement reaction, as metal is being displaced. Next is an oxidation reaction. According to the classical or earlier concepts, oxidation is a process that involves the addition of oxygen or any electronegative element, or the removal of hydrogen or any electropositive element. For example, S is added up with oxygen to form SO2, or from H2O, hydrogen is removed, forming oxygen. At this point, as we had studied the oxidation reaction, we need to see the opposite one as well, which is a reduction reaction. According to the classical or earlier concept, reduction is a process that involves the addition of hydrogen or any electropositive element or the removal of oxygen or any electronegative element. For example, from SO2, oxygen is removed to form S, and to the oxygen, hydrogen is added to form water. We can summarize these two reactions as oxidation means addition of oxygen or the removal of hydrogen, and the opposite is the reduction. At last, let us see the double displacement reaction. A double replacement or double displacement reaction is a reaction in which the positive and negative ions of two ionic compounds exchange takes place to form two new compounds. Double replacement reactions can form precipitates, gases, or molecular compounds. Occasionally, a reaction will produce both a gas and a molecular compound. This can also be understood like AB plus CD gives AD and CB. Examples of double decomposition reactions are precipitation reaction. Two solutions of soluble salts are mixed, resulting in the formation of an insoluble solid, precipitate. A plus soluble salt B gives precipitate plus soluble salt C. Like NaCl plus AgNO3 gives AgCl white precipitate plus NaNO3 is formed. Neutralization reaction. An acid and a base react with each other. Generally, the product of this reaction is salt and water. Acid plus base gives salt plus water. This can be seen when NaOH reacts with HCl to form water and salt. As we reach the end of the module, let us summarize. First, we had seen the difference between physical change, which doesn't result in the formation of a new substance, while chemical change results in the formation of a new substance. Next, we saw the different types of chemical reactions, which are as follows. Combination reaction A plus B gives AB. Decomposition reaction AB gives A plus B. Displacement reaction A plus BC gives AC plus B. Oxidation reaction addition of O or removal of H. Reduction reaction addition of H or removal of O. Double displacement reaction AB plus CD gives AD and CB.